everyone, thank you so much for clicking onto this video. We're going to be looking at tests for ions today. So we're going to look at the qualitative analysis of ions on a test tube scale, processes and techniques needed to identify the following ions in an unknown compound. So we're going to be looking at anions, the carbonate ion, chloride ion, bromide ion, iodide ion, and the sulfate ion, and for all the cations, the ammonium ion, the copper 2+, iron 2+, iron 3+, manganate 2+, and chromium 3+. Now we're going to look at the analysis of inorganic compounds. So the first test that we can do is the test for carbonates and hydrogen carbonates. And so what we do is we add any dilute acid and observe effervescence. So that's just the fancy word for bubbles. And then we bubble this gas that's produced through some lime water to test if it is carbon dioxide or not. And if the lime water is fizzing due to carbon dioxide, then that means that there's a carbonate or a hydrogen carbonate present. So in this example, we have sodium carbonate reacting with hydrochloric acid to form sodium chloride, the water, and carbon dioxide, which turns the lime water cloudy or makes it fizz. And in the second example, we've got sodium hydrogen carbonate, and it does the same thing, but it only produces 1 mole of sodium chloride this time and uses only 1 mole of hydrochloric acid. The second test that we can do is the test for sulfate ions. And what we do first is we add some dilute nitric acid to the test tube so we can get rid of all the carbonate ions that could react with the barium 2+ ions to form barium carbonate, because that's also a white precipitate. And we then add some barium chloride solution to the solution that we're testing. And a white precipitate should form if it does contain sulfate ions. And a really important note is that we don't use sulfuric acid to acidify the barium chloride solution because it contains sulfur ions, so it would interfere with the results. And what we have happening is that barium 2+ ions are reacting with sulfate ions to form the solid barium sulfate. And barium sulfate is also the barium meal that you have to outline your gut. So it's very, very insoluble, and that's why we can tell when it's being produced. And the third test that we can do is testing for ammonium ions. And what we do is react it with warm aqueous sodium hydroxide to form ammonia. And this gas which is formed should have a really pungent smell and also turn damp red litmus paper blue if ammonium ions are present. And what's happening is that ammonium ions are reacting with hydroxide ions, and this forms the ammonia, which is the pungent smell, and also water. So now we're going to talk about a test that we can use to identify halide ions, and we actually use silver nitrate. So what we do is we acidify the solution with nitric acid and then add silver nitrate dropwise. And the role of nitric acid is to react with any of the carbonates present to prevent formation of the precipitate silver carbonate, which is also a white precipitate. And this would mask the desired observations. And this is why we use nitric acid, so we can get rid of all the carbonates, because we form sodium nitrates and water and carbon dioxide. So fluorides produce no precipitate, chlorides produce a white precipitate, bromides a cream precipitate, and iodides a pale yellow precipitate. And these are the ionic equations that we have. So a silver plus ion reacts with a chloride minus ion to form a solid precipitate of sodium chloride, and the same with bromides and iodides. The silver halide precipitates can then be treated with ammonia solution to help differentiate between them if the colours look really similar. So silver chloride dissolves in dilute ammonia to form a complex ion, and this gives a colourless solution. And silver bromide dissolves in concentrated ammonia to form a complex ion, which is a colourless solution. However, silver iodide does not react with dilute or concentrated ammonia because it is too insoluble. So now we're going to talk about how to test for transition metal ions. So what we do is we first look at the colour of the solution. So Cu2+, the solution should be blue, and Fe2+ should be pale green, Fe3+ should be orange, manganate should be pink, and chromium should be purple. And then what we do is we add some sodium hydroxide to all of them. And basically what should happen is there should be an acid-base reaction or a hydrolysis reaction occurring where the hydroxide ions which are being added are taking away the H pluses from some of the water ligands which are attached to the central metal ion. And so what forms is a precipitate. So for example, if we had the copper 2+, we would start off with this ion, and then we would add some sodium hydroxide, and we would form this precipitate. And also 2 waters. So because the new complex which is formed has no charge, it's a precipitate. And for the example of copper, it should be a blue precipitate. And so we can do this with all of the solutions, just adding sodium hydroxide to them and looking at their precipitate colours. And then we can match them to this table. And so this is how we can identify between different transition metal ions.